Hi dear students, welcome back to my session. In our previous sessions, we discussed basic theorems. Those are superposition theorem, Thevenin's theorem, and we discussed the source transformation techniques, how the source is transformed from the non-ideal current source to the non-ideal voltage source or vice versa. And further, one of the important theorem in the among the 5 theorems as per your syllabus is the Norton's theorem. So if you understand the clear about the Thevenin's theorem, then only it is an easy way of solving by Norton's theorems problems also. Now let me move directly to the what theorem states. What theorem states? This is a theorem statement. So Norton theorem statement is any linear two terminal circuit can be replaced by equivalent circuit consisting of current source in parallel with the resistor Rn. As you know, the source transformation, when we convert voltage source plus and minus, which is the series with the resistance. If you want to convert this voltage source to the current source, the voltage source must be the resistance which is series with the voltage source. Then only this source can then only I can convert this voltage source into the current source. If my voltage source is like this, plus minus, if my resistor is short circuited, you can't convert this type of voltage sources to the your required source transformations. So the source transformation is valid when voltage source with the series with the resistance or with the current source which is a parallel with the resistance, then only the source transformation technique is valid. Similar way here. Norton's theorem equivalent circuit, as you know, Thevenin's theorem equivalent circuit is very similar to the non-ideal voltage source. How the non-ideal voltage source is represented? Plus minus, and this is non-ideal voltage source representation. This is R, this is V. If I use same this equivalent circuit in the Thevenin's, the R will become a RTH, the V will become a VTH, right? So this is nothing but a Thevenin's equivalent circuit. Same manner, can you draw non-ideal current source equivalent circuit? Let me draw this. Non-ideal current source equivalent circuit is look like this. Current source which is parallel with the resistance. Here are the outer terminals. Here the resistance is R, the current is nothing but I. When you are using same type of equivalent circuit in the Nortons, the R will become a Rn, the I will become a In. Rn is nothing but a Norton's equivalent resistance, In is nothing but a Norton's current. RTH is nothing but Thevenin's equivalent resistance, VTH is nothing but a Thevenin's voltage. So this is called TEC, this is called NEC. Norton's equivalent circuit. So based on this two, you are going to be shrink your any type of large and complicated and complex circuits into this small mode. So you can convert any complex type of circuits into this two representative element model. So here the statements, let me read the statement again. This statement is very important in the examination point of view also. So any linear two terminal circuit can be replaced by the equivalent circuit consisting of current source and parallel with the resistor Rn, where In is the short circuit current through the terminal and Rn is the input or equivalent resistance at the terminal when the independent sources are turned off. So this is very important. The independent sources is nothing but your voltage source and your current source. How the voltage source can be represented with the short circuit? When I am finding the equivalent resistance, all the voltage sources will become short circuited, and all the current sources will become a open circuit, because my internal resistance of all voltage sources is 0 and my internal resistance of all the current sources is infinity. By representing of this current source, I will open these contacts of the current source wherever the current source is presented. and wherever the voltage source is presented, I will short circuit those terminals. Hope you understand. Already I discussed these concepts on my previous videos. Please, if you have any doubts about this, kindly go through this all the videos. Kindly watch thoroughly. Don't skip. Hope you clear. So this is about the statement. Now here this is the original circuit. This is called original circuit. Sorry, right. This is called original circuit. I'm converting this original circuit into the neck, Norton equivalent. So A and B terminals are, I'm not changing. A and B terminals are fixed. In the linear two terminal circuit, this is circuit box. In the circuit box, there is plenty of resistances. Those are connected in different fashion of. Those are connected in a different fashion, like this, like bridge type. They can connect in different fashion, either based on their requirement. So these all types of complicated networks are built in this terminal box. So these all are complicated networks, including with the independent sources. You can convert into this two mode of elements, either maybe passive or either maybe active elements. So one should be active, other one should be passive. So you should convert into the single active and single passive elements to, from the many complicated circuits, many complicated representation to the single active and single passive element mode. So here the main important words are short circuit. The current IN is nothing but a short circuit current throwing to the terminals when you are short circuiting. RN is nothing but an equivalent circuit resistance. So when the independent sources are turned, this is completely one sentence. This is completely one sentence. RN, how you are going to be measured the resistance RTH, similar manner. You need to be measured RN. As you know how to find the Thevenin resistance in the network, same principle you should apply to the Norton's theorem also. In place of TH, you need to be write it as a N. So here the proof of Norton's theorem will be given in the next section. For now, we are mainly concentrated on the how to get Rn and In. See, please here observe the procedure how to get the Rn and the In. So here we can find the Rn in the same way of RTH. As I said, Rn is nothing but RTH. As you know how to solve the RTH. Simply all the replace the independent source with their internal resistance. You should remember one point over here. All the voltage sources, all the independent sources which are replaced with this internal resistances. So here you need to be write this word all. Here under this line you need to be write this word all independent sources are replaced with internal resistances. What is the internal resistance of voltage? 0. What is the internal resistance of current? Infinity. These all are ideal cases. If I given the voltage plus minus voltage 5 volts, this is nothing but a ideal voltage source. If I given the voltage source plus minus with a value of resistance 5 volts comma 0.2 ohms, this is nothing but a non-ideal voltage sources. So here 5 volts comma 0 ohms, here the 5 volts comma 0.2 ohms. So then when I'm finding Rn or ITH, this means this entire voltage source is going to be replaced with the internal resistance. What is the internal resistance? 0 ohms. How you represent the 0 ohms in the circuit? By making the short circuit. Similar manner, entire voltage source is replaced with the internal resistance. What is the internal value of resistance? 0.2 ohms. Then you can remove this and represent with the ohms, 0.2 ohms. So this is way of representing of internal resistance for the finding of Rn or Rth. Hope you clear. Next, now how to find the IN? Let me find the IN procedure. Here the IN is clearly mentioned when the current will flow in the line. I will repeat my question. At what instant, at which instant the current will flow through the line? When either maybe circuit will be closed or circuit may be short circuited. In these two conditions only the current will be flow. If my load like this, let me draw one diagram for you. Right. If I given the circuit like this, plus and minus, voltage, so resistance, 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 and resistance. Here the resistance, resistance. Here one more resistance. From here, a given connection. So these are the output terminals A and this is B. Here I have bulb. Here I have bulb, which I have the 60 watts. This is terminal of A. This is terminal of B. Until and unless if I didn't connect this bulb to this A and B terminals, is my current is flowing between A and B terminals? No, right? Because there is no connection of A and B terminals. If you give the connection like connecting the bulb or load, or you can make one thin or thick wire by making short circuiting of this A and B terminals, then the current will flow. There are two conditions only the flowing of current is a possibility. One is for the making short circuit between the terminals, or you can connect load across the terminals. So here what I am doing is I am making this short circuit current, finding short circuit current across A and B terminals. I am making this shorting of this A and B terminals. Then I can find the IN across this. Before our previous theorem, in Thevenin's theorem, we make if you want to find the voltage across the A and B terminals, your short circuit is not required. Over there, the simply you can open circuiting of your element. If you connect the DMM over here, you can get the voltage on this display. But here for the finding of current, you must give this some path between this or between the output terminals or between the open terminals. Then only the current will flow. You can easily measure the flowing of current between through the winding, through the wire, through the connecting wire. So that is about this finding of this IN. So here that is what I shown in the diagram. Please observe this. Observe the diagram here, left side. Here I make the short circuiting. After this short circuit, the current will flow. That current name is called IN. IN or ISC both are same. ISC is nothing but a short circuit current. IN is nothing but a Norton's short circuiting current. So now you need to be find the IN. How you are going to be find the IN? You can find the IN by doing like this. So dependent and independent sources are treated same way as a Thevenin's theorem. Same Thevenin's theorem you need to be treat. Observe the close relation between the Norton's and Thevenin's. The Rn and Rth are both are same as equation. Then for the finding of IN, how you are going to be find the IN? IN is nothing but a Vth by Rn. You can find the voltage across these terminals. By using those voltage, you can making this short circuiting. You can get Rn by dividing Vth and Rn. You will get In. So this is way of finding the. This is way of finding the IN and Rn in the Thevenin equivalent circuit. Since VTH is nothing but a VOC, same voltage, so that is nothing but RTH is Rn, both are same. Since VTH, IN, RTS are related according to the equation to determine Thevenin's and or Norton's theorem, we can find the open circuit voltage VOC across the terminals AB, short circuit current ISC across the terminals A and B, and the same. అంతే కదా VOC నువ్వు ఎందుకు ఫైండ్ చేస్తున్నావు? Why you are finding the VOC? For the finding of IN. Why you are finding ISC? For finding of IN. Right? So ISC అన్న IN అన్న ఒకటే, VOC అన్న VTH అన్న ఒకటే. If you are getting VTH, you can find the IN easily because you know the RN, or you know the RTH. So if you observe the problem, then you will get to know what exactly Norton's trying to say. Let me take one example problem. Let me read the problem. Find the Norton's equivalent circuit for the circuit shown in figure. So here, how many dependent sources? How many independent sources? 2 amperes and 12 volts, 8 ohms, 8 ohms, 2 dependent sources. All are independent elements. Means 2 active, all are passive. So across Norton equivalent across AB. So you should find the Norton equivalent circuit across AB. Means the entire circuit you need to be convert into IN, which is in parallel with the resistance of Rn. Here that A and B terminal should be there. Means entire this network, means 2, 12, 4, 8, 5, 8, that entire this complex network you need to be convert to the single current source and the which is parallel with the resistor, this IN and Rn across A and B terminals. So first let me find the Rn. Rn is nothing but RTH. For that you should, so first you need to be find the Rn. Let me find the Rn task. Same diagram you need to be use. Let me take a screenshot of this. One moment. Shift open screen. So I'm taking screenshot of this. Now I am finding this. I'm finding by using the circuit Rn. So how to find the Rn? For the finding of Rn, wait. So now I'm finding the Rn. For the finding of Rn, I need to be follow the two important rules. All my voltage sources which is replaced with this short circuit, all my current sources are which are replaced with the open circuit OC. Here, where is the short circuit, where is the current sources, where is the voltage source? Let me find. Here, this is the current source, so let me remove this. Let me remove this current source because current source is going to be open circuit. Let me remove, right? Next, what about this voltage source is going to be short circuit. I am making short circuit connection, right? Now find the Rn or RTH across this Rn across A and B terminals. So how you are going to be find? This is going to be eliminated. This entire part is going to be eliminated. Let me remove that. So this entire part is going to be eliminated. Next, since because there is no current flowing, Why there is no current flowing means there is no resistance, and that is since that is open circuit. Since these three are in series mode, 8 4 8, these three are in series, so hence 8 plus 4 12, 12 plus 8 20, the entire the resistance will become 20 ohms. Let me convert into the single mode of resistor, that is 20 ohms. Let me remove this, because these are three are in series. I am deleting and I am making, so the resistance will become 20 ohms. This 20 ohms and this 5 ohms are parallel, then my Rn will become 5 ohms which are parallel with the 20 ohms. Then you will get some value. That value is nothing but, as per your, that value is 4 ohms. 20 into 5 by 20 plus 5, 4 ohms. So now you got this, you got on the Norton's equivalent, you got only Rn, right? You got only Rn, right? Across A and B terminals you got only Rn, that is 4 ohms. But IN, you need to be find the IN also across A and B terminals, right? Let me find the IN now. For the finding of IN, this is A, as you know. This is A, this is B. So now you need to be find the IN. For the finding of IN, there is a formula here. The formula is given on your on our textbook. So here, apply the mesh analysis, or you can find the VTS directly. So this is finding of Rn. So you can make the short circuit of this A and B terminals. After the making of short circuit, there are two different currents which are flowing through this. You can find by using different methods. See, here they use different methods. Let me find one by one. Now let me find the IN. So here for the finding of IN means, before the finding of IN, you need to make short circuit between these two terminals. Wait, let me add this decline. So you need to find the IN across this A and B terminals, right? So here there are two sources are there. How you are going to be do finding of IN? Is there any methods? Mesh analysis, nodal analysis, KCL, KVL, loop equation based on the loop currents, and all those methods. Which method is suitable for this finding of IN across A and B terminals? So I'm going for the mesh analysis techniques. So here, how many meshes? 1, 2, 3 meshes, but this mesh is not valid. Why? Because as soon as the current is delivered here, always choose the least resistance path. So you can use mesh analysis as soon as the current flowing through this, it is divided into the two paths, but current always choose the least resistance path, since current will not flow through this 5 ohm resistor. Then I am removing this 5 ohm resistor. When I am making the short circuit of A and B terminals, then the 5 ohm resistor is invalid. So I am removing this. Right. Now your work need to be find the, here I have one loop, here one more loop. For the name of this loop is I1, for the name of this loop is I2. For this I1 loop, I know the current 2 amps. There is no need to be write this equation. This is 2 amps. For I2 loop, I don't know the current. I2 is nothing but IN. If you find the value of I2, that is indirectly you are finding IN also. I2 and IN both are same because both are in series. I2 is equals to IN. So right now I am writing the equation for the loop 2 only. Since I know the loop 1 current, I1 is equals to 2 amps. What about the loop 2 current? How to find the loop 2 current? Let me write the loop equation. For this, I am directly writing the loop equation. Already you know how to write the loop equation, all the concepts. So I am writing directly equations. How much value of resistance? 8 plus 8 plus 4, 20 value of resistors to the current I2 minus how much value of resistors 4 amps is a common of I1 also, minus 4 I1, and my battery is minus 12 is equals to 0. If I substitute first equation in second, I1 is equals to 2, then 20 minus I2 minus 8 minus 12, then I2 will become a 12 by 12 is nothing but a 1 ampere. I2 is 1 ampere. Since I know the since I equate the I2 is equals to I1, then I1 IN is equals to 1 ampere. What is the value of what is the Norton's current through the A and B terminals is 1 ampere. Now you know the IN and you know the RN. It means your work has been done. See here, IN how much? 1 ampere. So there are two different methods. Kindly observe. You can make a short circuiting of this A and B terminals. You can measure current, or you can make a open circuit of this A and B terminals. You can measure OC. VOC is nothing but a VTH. If you do the dividing of VTH with RTH or RN, then you can find the IN. That is one of the method. But here also finding of VTH, you need to be apply the mesh analysis technique. So this is way of finding the Norton's equivalent circuit parameters. So please kindly solve few problems related to this Norton's theorem. Thank you. If you have any doubts, please let me know. Thank you one and all. Bye.